Okay, so now we're coming down the home stretch. So essentially, you know how to use the unit circle to find sine, cosine, tangent, cosecant, secant, and cotangent. Um, Now we need to talk about how to use the unit circle to find inverse trig values. Now remember, trig values take in an angle and spit out a ratio of sides, depending on which trig ratio you're working with. Inverse trig values take in ratios and spit out angles. Now, when we're using the unit circle for these, for this year, all you're really going to have to be able to do is to find inverse sine and inverse cosine, because those are the things that are directly on the unit circle. So just remember again, on the unit circle, cosine is the x, sine is the y, and the easy way to remember that, it's alphabetical order. Cosine comes before sine, x comes before y, x value is always cosine, sine value is always y. All right, so if I wanted to find, say, the inverse sine of square root 3 over 2. Now, the way this works is I'm looking for angles, and I'm looking for any angles that give me a sine value of square root 3 over 2. So I know that the sine value in the unit circle is the y value. So I want to find the angles on the unit circle that give me a y value of root 3 over 2. So I look around the outside, here's one, and here's one. Now, if I had wanted the angles in radians, I would write pi over 3 and 2 pi over 3. If I'd wanted it in degrees, I would have written 60 degrees and 120 degrees. And typically when they ask problems like this, they'll tell you whether they want radians or degrees. So let's say I wanted radians on that one. Okay? Now, before we go on to the next example, I want to note that there are actually an infinite number of angles that could have given me this root 3 over 2. I could have gone to pi over 3. I could have gone around another 2 pi or another 2 pi or another 2 pi, or I could have gone to that angle by going around in the negative direction. But for purposes of what we're doing, we want angles that are actually on the unit circle. So a lot of times you'll see a restriction in the problem that says, give me an angle between 0 and 360, or give me an angle between 0 and 2 pi. That way we're only listing the things that are actually on the unit circle and not having to get all those coterminal angles that are there too. So let's do another example. Let's do the inverse cosine of negative 1/2. So again, I'm looking for an angle that gives me cosine. Let's do it in degrees this time. Cosine is the x value. So I want any coordinate pairs that have an x value of negative 1/2. So let's see, there's one here, and there's one here. So the degree measures of those would be 120 and 240. So literally when you're finding these inverse trig values, it's finding the coordinate on the unit circle and getting the angle from it rather than going to the angle and then picking out the appropriate coordinate. So one more just to make sure we've got the picture. Let's do the inverse cosine of negative 1. So again, cosine is the x value. So I want to find the point or points on the graph that have an x value of negative 1. And the only one that happens here is this one. So if I would have been looking in radians, I would have answered pi. If I'd been looking in degrees, I would have answered 180 degrees. Now, one last thing before I stop the video. Whenever you're finding these inverse trig functions using the unit circle, I'm only going to give you values that are actually on the unit circle. There's not going to be any find an inverse cosine of 2/3 using the unit circle. If you have a value that's not on the unit circle and you're trying to find the inverse trig function of that, it will require a calculator, and you would use a calculator for that. All right? Cool.